Hello, my name is Michael Hart. I'm a Senior Director of Product Management at Rockwell Automation. I am joined today by 3 technology leaders across Rockwell's partner network to discuss the challenges automotive manufacturers face as it relates to production and quality management. We'll dig into the opportunities, threats, and challenges they face in that industry. Thank you all for joining us today.
Thanks. I'm Chris Hardwire, the Vice President of Strategic Solutions at MapleSoft. We're a software technology company that specializes in mathematics and simulations and been around for 40 years and seen a lot in the business ever since.
Yeah, I'm Dean Horn with Softing. I'm the Director of Marketing. We've been a partner with Rockwell for 30 plus years. We make communication devices that plug right into the chassis of control logics and compact logics, and also asset management solutions that connect Rockwell to third-party asset management software.
So I'm Mark Arnold with SMC Corporation of America. I'm the Electronic Product Sales Manager for SMC. SMC has been primarily known in the past as a pneumatic automation company, but we really branched out and we're adding a lot more to our feature sets and adding product that really relates well with Rockwell on the electronic side and data collection and so on.
Maybe we dive straight in. Given the pressures facing the industry and ensuring the health and efficiencies of our asset on the shop floor, can you speak to how you're seeing customers in the automotive industry space address the complexities of asset management?
Asset management's tough. You've got PLCs that range from model numbers and even different vendor types. You have field devices also from different manufacturers, and even asset management software from other manufacturers. So the challenge of them aging in place and connecting all of those together, a lot of people think that's just not possible. So I'm going to do this with maybe a route-based solution. I'm going to walk around the plant. That can take hours sometimes just to walk to the device and troubleshoot it, and then you have to come back to inventory, grab parts, and then make that trip back out there again. So yeah, there's a lot of time spent there, but Rockwell is pretty innovative in this way because they partner with companies that can provide solutions that connect these third-party devices together. And that's one of the things that Softing does, is connect those third-party devices to asset management solutions.
As we delve deeper, maybe into the intricacies of our assets, it becomes evident that enhancing control systems really is paramount to the success of the business and really focused on minimizing the disruptions. Mark, building on that notion, maybe we'd love to hear your insights on how customers are actively optimizing their control systems to boost yields, manage machine cycles, and minimize disruption through the manufacturing process.
You need to understand what your equipment is doing, establish a baseline, and then monitor it as it progresses in the life of that equipment. And one of the things we're working on is how we can get a fingerprint of that machine when it's new. So we're bringing in data from different sensors, starting with the pneumatic system, but we can bring in other systems as well, bring in other sensors. And now we can monitor the health of the machine. We can take that data, and now we can start doing that predictive maintenance, reduce downtime. And even on the quality side, if something's starting to creep away from the standard baseline, we can start seeing that. So we're providing that raw data that can go up and be analyzed by the data and analytics engines that are out there in the marketplace.
Sure. I gotta imagine that having effective asset models to the solutions that are put in place with control systems as well as the asset management system, that's really kind of what helps speed transition and time to value. Well, fascinating insights into the transformation power of this technology. And sometimes I know in my career I've wished to have a crystal ball, and sometimes simulation-based technology can be that crystal ball. So Chris, help us understand, how are you seeing simulation-based technology kind of advance things for the automotive industry?
I like how you introduced it there with the crystal ball, because I think that's where I'm seeing a lot of the advancement, is the ability to predict real-world behaviors, right? And in the automotive industry, we're really trying to use the simulation technology to even simplify a complex work environment. I think with the movement in technology to go towards traditional drivetrains into electric vehicles. For example, there's a lot of unknowns that are being discovered, and a lot of engineers today are turning to new technologies on the computer instead of going to the manufacturing floor to test out an old prototype and make some tweaks. I could test that prototype on my computer, and I can make 1,000 different tweaks all at once and hit one button to simulate the behavior. So we're seeing simulation being used more and more in advanced technologies where there are a little bit more unknowns, a little bit more risks, where the design is not proven out.
As manufacturers embark on that journey of modernization, often the first obstacle they have is connectivity. So Mark, I'm curious, drawing from your experience, can you shed a light on how customers are encountering this challenge of connectivity?
So one of the things that we are looking at is the actual physical medium and the cabling in actual equipment. Running that Ethernet cable, let's say, to a robot end of arm tooling, it introduces problems for customers when that cable flexes and it ends up actually breaking and causes a major downtime issue. And in some cases, it can take them up to 8 hours to reroute that cable. So to getting around that, we introduced a new wireless system to go from the Ethernet IP to that end of arm tooling and being able to maintain that communication. So extending that communication from the Ethernet IP to the remote I/O that's on the wireless system. So that's really helped a lot of our customers in these situations. So limiting some of their problems with communication on moving things such as robotics or rotary dials.
Are you seeing a uptick in customers kind of moving to 24/7 lights out manufacturing?
I think so. I mean, when they can know that they can reliably run that without having to have a skilled tech to troubleshoot an Ethernet IP connectivity issue, because it's not as simple, with like a power connector. It's either on or off. Where you have the intermittent problems with Ethernet connectivity. So now we know that, hey, we can deal with this, have a machine that's going to run reliably. Don't have to have somebody that troubleshoots the communication. It's just going to run. So they can run that 24/7 with a lot more confidence.
Connectivity certainly lays the foundation for the next phase, which is effective data communication and data management. So, Dean, help us understand where you see data collection and communication playing a role within the automotive industry.
One of the things that I see a lot, though, is a lot of customers or plants don't implement asset management strategies until a device fails or until rotating machinery fails, right? So that's a challenge. And then one thing that's you don't think about is bidirectional communication sometimes. We think a lot about monitoring the information, but you can also leverage the business systems to download recipes and automate line changeovers and things like that. Where to start? Take a look at your KPIs, your key performance indicators. What challenges are you having? That's the low-hanging fruit and the things that you should probably go after and make a difference immediately.
Excellent. Are you seeing a particular space with either worker safety, quality, production kind of pieces that are helping customers focus on? Where do you see the initial trends?
Probably just efficiencies is what I'm seeing a lot of. Taking, in a lot of cases, the manual processes and reducing those to, into automated process. And that'll trickle down into safety too, because you get people out of harm's way of different things as well.
The richness of data can also enhance the accuracy of the simulations and the models you were talking about. So maybe, Chris, drawing from your experience, could you elaborate how you have worked with the modeling and simulation specific to the electric vehicle industry?
We've worked with automotive customers for many years now, and traditionally it started with drivetrain, vehicle dynamics, things like that, but we're seeing a big shift right now, actually, in two main areas. One is autonomous driving. So they're using our simulation models as a way to train the vehicles, train the computers that are driving the system, avoiding pedestrians on the road, and giving it really complex scenarios.
It's amazing.
Maybe you'll finally get us there. to self-driving.
To self-driving,
yeah.
It's on its way. It's yeah. So we've worked with Toyota, Nissan, Honda, before, but now these other companies, particularly in the United States, new entrants into the market are adding technology to vehicles, especially now with the advent of batteries and lithium-ion batteries in particular. These batteries are cylindrical, and you have different materials coming in to form the anode and the cathode inside, and it's delicate. You know, one company let me hold the anode material, and they said, "Hey, Chris, like try to break it," and I just went like this, and it just fell apart. Like easier to break than paper, right? So to rip than paper, and they're running these machines at high speeds with high accuracy to get the winding right, and they turn to us to say, you know, how can simulation technology actually help us predict what's going to happen, help us get better throughput on the manufacturing floor, and help us increase our quality, because it's about being competitive. It's about getting the volume out right now, and we're seeing huge success with that, and it feels good, going into these companies and them saying, we discovered problem A, problem B, problem C way earlier in the design cycle, whereas traditionally that would have showed up on the production floor, and we'd have to try to figure it out and waste a lot of material trying to get it right. So that's some of the things that I'm seeing right now, and it's an exciting time.
Yeah, I can imagine. Being able to run the amount of iterations associated and pulling through the waste associated to sustainability and all the effect associated to that, the cost savings, et cetera, the time savings of bringing product to market. It's amazing to hear that in real life examples. Maybe we do this. Where do each of you see the automotive industry as it relates to technology over the next 5 to 10 years?
So you just mentioned the word sustainability. It's not only the end product, whether it be electric vehicles or hydrogen or whatever the future powertrain is going to be, it's also the manufacturing process. It's very key for these manufacturers to also be green in their manufacturing. Having the ability to reduce that the energy consumption in the manufacturing process, measure it though, it's data driven, a lot of this, so you're going to see a lot more information on the manufacturing process, down to how much compressed air did I use, how much electrical energy did I use for the motors to actually do this process. They're going to do whatever they can to reduce their consumption in the manufacturing process and not just the end product.
I think AI is maybe the obvious answer, but I mean, what that really means is providing some context for what's going on. So if I'm monitoring vibration or temperature flows and pressure, I can put that in context with production schedules, right? If I got one more part to make, maybe the vibration doesn't matter so much, I'm gonna make it. If I've got 100 more, I need to adapt what I'm doing so I can make it to that 100th part. So I think, providing some context around what we're doing in manufacturing could be the next level.
I do see, and you said AI is the obvious answer, but that vehicles, becoming smarter, becoming more of like how your mobile phone became your companion, and it's a solid state device, and you just rely on it, and you don't have to think much about how to use it. And I think vehicles are headed that way. It's more of a solid state. User experience goes way up. Reliability, predictability goes way up. Safety goes way up. And using simulation technologies to design and manufacture those vehicles, I think that those technologies, I know from my company, MapleSoft, are getting smarter as well, where you can ask the software to do tasks and run scenarios for you, as opposed to thinking about how to do that ahead of time. So I think overall, it's going to get smarter, and things are going to get really cool in the next several years. I mean, we all have common customers, we all have common partners in this space, and at the end of the day, they all have common challenges, right? They want to get to market faster. They want to innovate. They want to leave this world a better place than when they started.
Seeing the technology come to it is really exciting from my side of things, and I think it's bringing a fresh perspective to maybe old industry expectations of what happens on the shop floor. But pulling the technologies that all three of you talked about, bringing it together, I think is really what's going to propel all industries here in the next 5 to 10 years. Well, thank you for joining me today, and thank you for sitting with us. And I trust that you found great feedback out of this rich conversation. And until next time, keep driving progress forward.